Welcome, students. Uh, Welcome to another exciting session of power electronics. As I told earlier, that we followed the entire structure of power electronics for the 5th semester, one by one or step by step. That eventually you are being capable to execute problems associated with the subject. Myself, Sandeep Chakraborty, Assistant Professor, Electrical Engineering Department of Regenerative Education Research Foundation group of institutions. In the previous lecture, we have discussed about a particular numerical type, and again, we moving forward to another type of numerical, which help you to understand that if such things are being asked to execute during examinations, then what should be the process and how does it be very clear to all of you. Now, as per the questions are concerned, as you can see, for the static DC circuit breaker, there is a figure. We will let you show. The supply voltage is 200 volt DC and load current required is 10 ampere. A CRT1 has a turn-off time of 20 microsecond. CRT2 has a holding current of 5 ampere, 5 milliampere. Find the values of parameters R2C and load resistance. So we need to take a factor of safety as 2. So these are type of questions which have been given in university examinations, and as you can see, this comes from the thyristor chapter SCR, where we have to execute to monitoring the basic of thyristor. Now this is the figure as per the questions are concerned, and this is the T1, this is the T2. These are the two thyristors, and this is the capacitor C, this is the load, and this is the resistance, and this is the source voltage V1. So what we have given so far, T1 20 microsecond and holding current IH, that is 5 milliampere. One thing I must make sure that before you write up such kind of numerical, this parameter or these terms, that's the holding current or latching current, you must know. You must know the basic things, because thyristor, we all know, is a 4 layer 3 terminal 3 junction devices, and the current which is associated with its turn-on process, that is latching current, and the current which is associated with its turn-off process, that is holding current. Considering the idea of such kind of basic things, moving forward to the explanation of the numerical, as far as the figures are concerned. So what is the given data so far, T1 and the holding current IH. Now how do we execute? Suppose this is R2, the resistance, and as per formula EDC by IH. EDC, that means the voltages with the holding current, and these are the given data 200 by 5 into 10 to the power 3 as per the questions. So this is the R, 40 kilo ohm we have been executed so far. So first of all, the first first questions which need to be answered, that is the value of R2 we have calculated, followed by next one, that is load resistance, RL. RL means EDC by IL. EDC by IL, that means again the load voltages and the load current, which is 200 by 10, 20 ohm. 20 ohm, that is the load resistance for the second one. Next one, that is C, the capacitor of the amount of capacitor which have been required for this example. Now C somehow with the condition, that is 1.5 TQY by E if less than greater than equal to, if such conditions arise. So we just put or write down the basic equations, and as you can see, there are the datas are given, or the data we have already find out from previous two parameters. So as far as the data are concerned, so we have considered the 7 microfarad as an answer for the third one. So 1, 2, 3, these are the steps we have been followed to execute the entire problem. On the whatever the figures are given, whatever the data are given, if we go through with the basic formula or the basic steps, so we can easily calculate the numericals in a very easiest way. This is all I want to say to all of you, that don't think so much. Just try to understand the basic formulas which needed to implement according to the questions. Now, as I have executed in 2 or 3 to 5 lines, so you can also be executed in this same manner. So, considering the importance of all the questions, just try to go through with the basic steps and execute the problem.